So hopefully today we're going to be able to take you on a journey to explain how the industry is changing, how the technology is changing, and what impact that will have on the industry today. So for instance, here's a stat, right? The average post editor will do about 6,000 words post editing a day. That's the average. Now, that's not a number that we claim, it's a number that our clients tell us that's what they achieve, okay? A professional translator will translate about 2,500 words a day. If you're post editing machine translation, it gets to about 6,000. Supposing I told you there was a way to get that 6,000 number to 7,000 words a day, okay? So in other words, you'd see about a 16-17% increase in productivity. That would be a very interesting thing to do in your own business. It would actually improve the efficiency of your business and actually lead to greater margins, okay? So today, we're going to show you some interesting analysis that we've done with post editors and professional translators to show you how you can achieve that higher level of productivity, okay? So first of all, what is KantanMT.com? Well, KantanMT.com is a platform to help our clients or to help our community build statistical and neural machine translation engines. Okay, now statistical engines have been around for a long time. Rule-based engines have been around for a long time, but neural is very, very new in the sense that it's new for machine translation, because the very first paper on neural machine translation, believe it or not, was published in 1970. Okay, which was around the same time that rule-based systems came to the fore of the industry. So this technology is quite well versed or well seated in the industry, but we're now only reaching the point of time where we can exploit neural methods for the purposes of building sophisticated machine translation. And the reason for that is because of platforms like Kantan. We provide all the hardware, all the special software. You don't have to worry about that. You just basically choose, I want a neural engine or a statistical engine, and we do all the heavy lifting. Okay? Now, behind the Kantan platform is a fusion of technologies, because one of the really key aspects of the Kantan platform is that it's not just machine translation. Because you build engines with your training data, your translation memory assets, okay, your export from Trados or MemoQ or XTM and so on, because you build engines with that bilingual data, we actually build you a cloud-based translation memory. So when you're translating using a Kantan engine, we're fusing translation memory technology and machine translation technology with a load of rules in between there to give you the highest possible outcome. And that's very unique in the industry. Most vendors, in fact, all machine translation vendors today are pure machine translation. We've fused the best of two technologies together to give you higher levels of accuracy. Now, the Kantan environment only does three things. It helps you customize engines, it helps you improve those engines, and it helps you deploy those engines. And that's all we do. When we look at all the features that we have on our platform, we boil it down into those three main activities. Can we help our clients customize engines? Because we know customized engines will deliver higher levels of quality. And if we deliver higher levels of quality, our clients or our community will do less post-editing, and that means jobs will run faster and more efficiently. So we do three things: customize, improve, and deploy. Now, how big has the Kantan platform become? Well, today, guys, believe it or not, we host about 10,500 engines on our platform, okay? So we're probably the biggest platform for customized MT in the industry, and we're really proud of that number because of two things. Firstly, we're not building those engines. The Kantan community is building those engines, which is great. So for the first time in the industry, we've empowered a whole range of clients to control their own destiny when they're building machine translation. And that's really important, because think of this, guys. I started in the industry 30 years ago, and there was consultancy companies that went around to integrate translation memory into localization service providers. That was their business. Now, we would nearly laugh at that today. Would you hire a consultant to come in and teach you about translation memory? Well, guess what, guys? 30 years ago, yes, you did do that because it was such a new technology. Well, with the advent of platforms like Kantan, now our clients, our LSP clients and our ISV clients, our independent software vendor clients and our e-commerce clients are now controlling their own destiny and can actually build their own systems themselves. And the reason they do that is because they have a unique requirement to deploy them differently. They have a unique requirement to integrate them into their content management systems that in some cases we don't have any knowledge about because it's a proprietary content management system. And more importantly, they can customize the systems using their data. And that means they achieve higher levels of translation quality. At the moment, we host 534 billion words of training data on the Kantan platform. Okay? Now, 534 billion is a big number, but when you say that that's actually 500 billion, it even sounds even bigger again. Okay? We're only counting the source words here. If I was to count the target words and the monolingual data, we're running at about 1.2 trillion words at the moment. Okay, so we're well up in the trillion word category at this stage. And this year we've translated about 8.5 billion words so far on the platform. Now when I say we actually didn't translate anything. Our clients, the Kantan community, translated that amount of words. So, who uses the Kantan platform? Well, here's a list of clients, a small list of our clients. We deal with small to medium-sized LSPs all the way up to the largest LSPs in the world. In fact, the second biggest LSP in the world, language service provider, we have 3 people from that company today here in the audience, use our platform, and they have about 100 statistical engines and about 10 neural engines on the platform at the moment. So that's TransPerfect Corporation. So they do a lot of machine translation on our platform. And then we deal with a lot of e-commerce companies, a lot of automotive companies, and everything kind of in between there as well. So it's quite a diverse range of clients using the platform today. So I mentioned earlier on that we only do 3 things. We help our clients customize or build engines, we help our clients improve those engines, and we help our clients deploy those engines. And in order to achieve that in a highly automatic and efficient way, we've built a whole range of technologies, okay? And this diagram here depicts some of those technologies that we've developed. So for instance, anybody in the Kantan community that's building a statistical or a neural engine, they use an interactive development environment called Build Analytics. And it actually analyzes the training of an engine and gives them tremendous insights on how to improve that engine. More importantly, it helps them improve that engine very rapidly. Okay, because the industry that we work in works at light speed, guys. Okay, I often joke about the localization industry that there's one thing that unites every vendor, and it's that they have clients that want more for less, faster. That is what unites this industry. So we have to do more for less, faster. And Build Analytics helps you get this graphical insight to the training process, and you can use those insights to actually improve the engine rapidly. Okay? Now, one of the key things about statistical systems and neural systems at the core is the ability of these engines to continuously self-learn. Okay? And it seems a bit of a crime to me that a lot of the machine translation vendors today only allow you to retrain your engines maybe once a year, when the core technology that underpins statistical systems and neural systems is continuous training. Okay? Now, we don't limit the amount of training opportunities or cycles on our engines. You can rebuild them every 2 or 3 hours if you want. There's just no limit. And the reason we do that is because the core technology is self-learning. Okay? So why would you inhibit self-learning by allowing only 1 build a year or maybe 2 builds a year, and they're going to charge you big bucks to do that? We don't do that for our clients. You can see then in the green layers there, we have an awful lot of technology that helps us improve engines. One of those green layers is called Gentry. Okay? Gentry is a technology, it's an NLP, natural language processing technology that we've built, which is a programmatic layer that allows you to extend most of the internal features of our engines. Okay? And some of our really advanced clients and some of our biggest clients in the world use that layer to extend our systems. Okay? So we build baseline systems, and then they use that programmatic capability to even enhance the engines more and tailor them specifically for their deployments. Now, if you look at the evolution of Kantan, this is just a very, very quick view of it. So we were the first platform to cloud-based platform that incorporated translation memory and machine translation under one roof. And by the way, our translation memory technology is called total recall. That's what it's referred to in our code. So when you hear us say we've got a total recall translation memory, that's what that is. Total recall is the name. A great name for a movie, but I think it's an even better name for a translation memory, total recall. We were first to introduce an interactive development environment for language engineers that build statistical engines. They could see, it's like an X-ray into how the training process goes, and by understanding the insights there, you can rapidly improve those engines very, very quickly. We were also the first to deliver predictive quality estimation. Let's look at one of the most unique challenges about machine translation. If I translate a segment into French, okay, how can I give you an indicator that that's a good translation? Okay, now let's go back and use translation memory. If I translate something using translation memory, I get a fuzzy match score that says this is 85% matched. And I use that 85% to say that this is a good translation. And believe it or not, that number drives the economics of our industry today. That 85% tells me that instead of paying 12 cents for every new word, I'm only paying 10 cents because it's previously translated by a translation memory. Machine translation systems traditionally don't give you a score to tell you how good the quality is. Predictive quality estimation does. It actually says, here's a translation from the engine, and this segment is translated at 92%. It's exactly the same fuzzy match score. And our clients use that to introduce tiered pricing for post-editing. Because the lower the score, the more post-editing you're going to do, the higher the score, the less. So you should actually gain that benefit by working that into the economics of the industry. Now, we'd like to say we were smart enough to build that technology ourselves, and we do have really smart people here, but we had to reach out to Andy Way's group in ADAPT, who's one of our speakers today, and that was a co-project that took, I think it was about 6 months work on that. And most of that work, guys, was working on the maths behind that predictive algorithm. Okay, and we actually now license that algorithm from the ADAPT Center. It was previously called the Center of Next Generation Localization. The new name for that center is now ADAPT. We then noticed our clients, in our client base, that they wanted to be able to translate documents instantaneously. Okay, so we set off with this great vision that we should empower everybody to build their own engines. And guess what, guys? Not everybody had the time to build an engine. So what we did was we went away and we built a system called Kantan Fleet, which is about 250 pre-built neural and statistical engines that are available off the shelf. So you just log into your account and you grab whatever engine you want and you can immediately start translating. And those engines are available, I think it's in seven different domains: legal, medical, automotive, technical, and so on. So they're just available today. And you would not believe how popular that feature is. In fact, Laura ran a usability study there in the middle of the year, and I think it was the #1 feature used on our site. Was that correct? Yes. Kantan Fleet. And we developed it because when we're listening to the community, we could hear them tell us, we need to get up and running in a number of minutes. And that's where Kantan Fleet came from, by listening to the community. We then developed a very interesting technology called LQR at the same time as developing neural. So why did we develop these two technologies together? If you think about the introduction of neural technology, we kind of tell everybody, and the papers in the industry say, that neural will produce higher quality translation, particularly more fluent translation. But unfortunately, that's not good enough for most of our clients. They have to prove that empirically and in a quantifiable way. Because if they have a production engine, they're not going to make this great leap into neural unless they know the neural engine is definitely going to outperform their statistical engine. Okay? And the only way to measure that difference is to give them a platform called LQR, Language Quality Review. It's a platform that allows you to rank the translations between different engine types, or to do a full multi-dimensional quality evaluation of translation. So it's the first platform in the industry that just automates the process of harvesting the feedback from translators to tell you how good your engines is. And the really cool thing about harvesting that feedback is that we can immediately inject that learning back into the engine to improve it even more. Okay, so we built that technology to help our clients compare the output of neural engines so that they could see for themselves, rather than take our word, they could do this evaluation themselves to see how good this neural technology is. Okay? Now, and then obviously we reached a certain amount of scale. So let's talk, so that's our progression of technology. Let's talk about the progression of the industry then. So we started off in the 1970s with rule-based, and with rule-based systems, I was working in Corel at the time. Believe it or not, I was one of the first to use rule-based systems. It was a system developed by Siemens called Metal. Okay, and we used that system and that was in the very early days. And then in the 2002, we moved over to Statistical Systems. And then in 2016, we started to look at neural. And I think the paper that really kick-started the real intense research on neural was, it's probably going to be one of the most famous papers ever produced now, is the paper by Google. Okay, it's probably going to go down as one of the most famous papers ever written. Not necessarily because of the accuracy, perhaps, of the research that was in the paper, but the actual conclusions that they developed. One of the conclusions in the paper, for instance, was that neural MT outperforms human translation. Okay, that was one of the conclusions. Probably a little bit over-marketed in that particular sense. I'm not too sure I'd agree with that sentiment, but certainly what they were indicating to the market is that this is not an incremental change. It's not an incremental step. It's a quantum leap. That's really what the underlying message in that paper was, okay? So there might have been a little bit of hyperbole used in it, but you can see now that we've gone beyond the incremental change in statistical systems to this big leap of improvement in neural, okay? And now what we have to go through is this period of exploitation. So this period is a period of exploitation of this technology, because remember, this technology was talked about in the 1970s, okay? So we started off with complex rule systems, okay? And incredibly difficult to build engines. And then somebody said, well, why don't we get a system to learn these rules? So we then switched over to statistical methods. And statistical methods, you know, you take a sentence, you break the sentence into phrases. That's why we call it phrase-based statistical systems. Then you actually look up the phrase in a phrase table. You extract the translation from the phrase table. And then what you do is you reorder the translation to make it more sound like the native tongue. So we have this breakdown into phrases, look up the phrase table, and then reorder. Okay, and that's what statistical systems basically are. It's those three steps. And then we go into this crazy world called neural. Okay, and just I'm telling you guys, we don't know how these systems work. We're getting such crazy translations, good quality translations out of them, and we can't actually tell you which neurons are being triggered to form the translation. Okay, now we can influence the decoder, but we can't actually tell you exactly how it works. Okay, but it is based on very sound technology. So today, this is what we're going to spend time exploring. This is the real exciting part of this. It's almost like all of our engineers have a new shiny thing to play with in the corner. New shiny thing called neural. So today we're going to talk about sequence-to-sequence decoders. Okay, because what a neural model is a sequence of tokens coming in this side, and we have to transform those into another sequence. So that's where, if you're reading any of the papers on neural, you might hear this thing called a sequence-to-sequence decoder. That's what we're using here. Okay, so you're going to hear that word throughout today. The other thing you're going to hear about today is recurrent neural networks, okay, RNNs, and that's just the type of data model that we're using to build high quality output. Okay, so RNNs, or you might hear a thing called CNNs as well. Okay, and that's not the news channel. Okay, it's a different type of neural network. We use an attention-based unidirectional RNN. I know that sounds really fancy. We're going to show you what that actually means later on. So we'll reveal what these fancy words mean. And at the center of this, what we're actually using is vectors to represent sequences, and a sequence is just another fancy word for a sentence. Okay, so what is a vector? Because if you don't understand vectors, it's going to be very hard to understand how neural networks work. So let me talk a little bit about vector. I'm going to simplify this a little bit and talk about building word vectors. Okay, supposing we were able to take a word and represent it as a single integer. Okay, but every word has a unique integer. A unique word. So it's like an ID for a word, okay? And we were able to build a model that looked at the context in which that word exists. So we look at the words to the left of it, and we look to the words at the right of it. So that gives us the context in which that word is used in a sentence, okay? That's the attention of that word, okay? Supposing we built a model based on that numerical computation, right? So that means we're taking a word, replacing it as an integer, putting it into a model, and now we can actually group all these integers together, okay? Something amazing happens, okay? What actually happens, believe it or not, is words that are semantically similar start to coalesce in a vector space. Okay, just by doing that. So I see the word university, and I look at the words to the right and the left of it, and I do the same analysis across a large corpus. What actually happens is words of a similar meaning start to coalesce together if I draw it in a vector space, okay? And that's what a vector is. So for instance, we'd see the word walking and walk appear close to each other. This is a three-dimensional vector space. I'm going to flatten this to a two-dimensional vector space in a second. You'd see things like Spain and Madrid, Italy and Rome start to merge together. They'd start to appear in a similar cluster. So if I take that story and do it over a large corpus and draw it as a two-dimensional vector space, what you see is the word university and college appear close to each other. Okay, you see the word down here, information and data starting to appear together. Okay, so this is what we mean by vectors. We move from the words, we mathematically model it, and words of semantically similar meaning start to converge. Okay, now this is the foundation technology for neural. Now, of course, we don't train a neural network on words. Okay, this is just a way of understanding a vector. We actually train it on sequences. Okay, but it's exactly the same principle. What you'll find, and Dimitar will go through this later on, what you'll find is sentences of similar meaning start to converge in the vector space, and that's the start of a neural network for the purpose of building machine translation output. Okay, so when you hear the word vector today, that's what we mean. Okay. Now, we know these neural engines perform better. How do we know that? Well, believe it or not, guys, we've tested them. Okay, and today you're going to see this graph 3 or 4 times, and we'll actually prove to you how well these neural engines work. The green bar is the output of a neural engine. You can see it's significantly bigger than the blue bar there, which is statistical output. So we've proved this using professional translators. So enough about the basics of what you're going to learn today. Let's talk about the speakers. So we have a great lineup of speakers, guys. And the first speaker that's going to speak today is Professor Andy Way. And Professor Andy Way is the chief scientist and advisor for this company. And he's going to talk about separating the hyperbola of neural systems from the reality of statistical-based systems. Okay, so he's going to give you a level-headed presentation on what to look out for, the pit stops, the pitfalls, and the differences between the two systems. Okay, it's very, very interesting. And I don't know if anybody has ever received a presentation from Andy Way before. You're in for a good time here. He's excellent, right? He's a great speaker. In fact, I think last year we tried to go to your annual talk on the campus, and we just couldn't get in. We couldn't get in. They actually closed the doors with so many students in there listening to them talk. Our second speaker then is Mindaugas, and Mindaugas is going to talk about his experiences using statistical systems and neural-based systems on the Kantan platform, and Mindaugas is sitting here in the front row. And Mindaugas took a great leap of faith about 3 years ago. He started using Kantan, and that was a brave thing to do 3 years ago, because the platform wasn't quite finished. We let it out for free, and we said, look, try it, see what you think, and be a bit forgiving if there's a couple of bugs along the way. We'll fix them as we find them. And he's still here today, and he's going to share that experience. And now, I haven't seen this presentation, so I hope you're going to treat us lightly and gently. But please give us your honest opinion. And then we have a workshop where we've lined up 2 top speakers. Dimitar, who heads up research labs within Kantan. Research labs is a kind of off-project research area where we develop technology on a slower scale, and as soon as it becomes commercializable, we move it into the commercial side of our business. Okay, so that's what Research Lab is all about. And then Laura is going to talk about validating, the approach we chose to validating Kantan Neural in an industrial setting. Okay, now the agenda for today then is here. So Andy is going to talk next. We're then going to have Mindaugas up as the next speaker. We're then going to have tea and coffee, because I think by then you're either going to know everything about neural, or you're going to be in definite need of some caffeine injection, one or the other. Hopefully it's both, okay? And then we're going to have Dimitar and Laura talk about Kantan Neural from A to Z. We're going to have a panel discussion at the end, because I'm sure you're going to have a lot of questions. And then we're going to go over and eat where Andy eats every day of the week. Okay, it's where all the smart people on college go. It's where all the professors eat. They've got white linen tables and they have waiter service. It's just fantastic. If you ever wanted to know where all your tax dollars are going, you're going to see it this afternoon. Okay, and the food is quite good as well. Okay, you don't eat the same food as the students, isn't that right, Andy? It's you don't eat the same food, so it's at a higher level. So. But anyway, that's where we're going to bring you today. So hopefully by the end of today, you're going to feel smarter. You're going to feel much better fed than the students going to college. And hopefully you'll have a good insight into what Kantan is and what Neural is as well. So thank you very much. So let's begin. Andy Way, thank you very much.